Day 76, Universal Gravity, Honors Physics, Problem 27. Starting way over on the right here, here's something we've done a couple times now once again. Force of gravity, your weight is mg. Universal force of gravity equation, gmm over r squared. Set those two forces of gravity equal to each other. The acceleration due to gravity on the surface of a planet is equal to gm, mass of planet, that is m sub 1 over r squared, the radius of the planet, or how far you are from the center of the planet. Now in this particular problem, it tells you that there's a 10 kilogram mass with a weight of 60 newtons. In other words, if I do a little side calculation, W equals mg, in other words, force of gravity equals mg, that's 60 newtons equals the mass of 10 times g, so g on this planet is 6 meters per second squared. So I'm going to plug that in for g. It also tells me the radius of this planet. And I know capital G. So I know capital G, I know the radius of this planet, and I know little g. Plug all those numbers in, and I can get the mass of the planet over here on the far right. Because what I want to really do is get the density of the planet. So the first step is to get the mass. Going back over here on the left, this is the symbol for density in physics. It's called rho. If you want to use capital D, you can. Density equals mass divided by volume. The mass here is the mass of this planet divided by the volume of this planet. Well, the formula for volume, which I don't expect you to know, I'll give you both of these equations on a test. It's 4/3 pi r cubed. Once again, don't forget the cube, the radius, but it gives you the radius of the planet in meters. You're good. 5 times 10 to the 6. So you can plug that in for the radius right there to get the volume of the planet. Over here you have the mass of the planet. Once you have both of those, you plug in here. Here's the last step. Take the mass divided by the volume. That'll give you the density. In kilograms per meters cubed. And they want the relative density. That means relative to water. So you're going to take your answer. That's basically your answer. I would even take that. But the relative density would be that answer divided by the density of water. In other words, the relative density is going to be that number divided by the density of water, which is 1,000 kilograms per meters cubed. So you'll have a number that's so many kilograms per meters cubed. So basically, relative density, the units cancel out. It's basically just your answer divided by 1,000, and then no units. So good luck. And once again, if you have questions, we'll address those in class.